so we're going to build a little bit on what we did last class in terms of factoring. And then we are going to use the factoring method to solve a quadratic equation, okay? So last class, what we talked about was greatest common factor. We looked at factoring by grouping, difference of squares, and then factoring trinomials when a is 1. So I want to just over here really quickly take a quick look at what we did when we factored a trinomial with a not equal to 1. All right, so if we had something that was like x squared minus 7x plus 10, okay, that's what I mean by a trinomial with a equal to 1. We've got 3 terms, 1, 2, 3. That a term is 1. Okay, so when we did that, we worked backwards. Okay, so if we think, again, maybe I'll add another example right here. So let's say I have something that's like x plus 2 times x minus 6. And if I said multiply that out, we would do x squared minus 6x plus 2x minus 12. And then we would combine like terms, and that would be our final trinomial. So when we did stuff like this last class, we thought about working backwards from here. So what we noticed was, all right, the 2 and the negative 6, well, when I do double distribution, those are the last 2 terms that I multiply together. So that's how I get this negative 12 here. And then I get that negative 4 because I had to combine these terms in the middle. Okay. So when I do this, we kind of thought about the same thing. Okay. Well, in order to get x squared, when I multiply this through, both of these have to be x. I know that these 2 last numbers here have to multiply to positive 10. They have to multiply to positive 10. And they also have to add to negative 7 because of what I'm going to get in this middle step. So I'm going to get x times this times x, or plus x times this. So they have to add to negative 7. So in order for them to multiply to a positive but add to a negative, both of those had to be negative, and then we would come up with 5 and 2 there. Okay. But this method right here only works when our a value is 1. Well, not every trinomial has a leading term of 1. So we need to know a different method for when it's not 1. Okay, so we're looking for when the coefficient of x squared is not 1. Remember, that's what your a term is. And this is our last method of factoring. So on the back, I didn't have enough room to put it on the front. This is a little flow chart that you can use when you're working on any of your assignments and you're trying to determine how to factor. So the first step is always, is there a greatest common factor? Okay? And once you answer this question, you'll just follow this flow chart down. Okay? So if we look at this first example, practice how to do that. So here is what I see. 6x squared plus 11x plus 3. There's not a greatest common factor. My coefficients are 6, 11, and 3. I can't take something out of all 3 of those terms. So on this flow chart, I'd follow the no. Then it says, is it a difference of squares? So remember, difference of squares, there's no b term. It would be something like x squared minus 49. Subtraction, 2 perfect squares. Okay? I'm not looking at that here. This is not a difference of squares. So I follow my no. Next question, is a equal to 1? Well, a was equal to 6, so no. So then it says, follow the how to factor, no GCF, trinomials. That's what this A to C method is. So it's kind of like this, because I do want you to think about working backwards, and we're just going to follow this method through. Okay? So when we think about what we're going to be doing, I eventually want my final answer to be 2 binomials multiplied together. Okay? If we think about what we would be multiplying, I know that my first 2 terms multiplied together, I'm going to have to get 6x squared. Okay? And there are going to be multiple ways to do that. Then here I'm going to get whatever this is times this, and then this times this, and then these last two terms as well. Okay? Well, because of this 6 right here, that last term is going to be whatever this is times this, plus whatever this is times this. So my first step when I'm when I'm factoring a trinomial with a not equal to 1 is actually going to be to multiply a and c together. So we're kind of doing that last step here. So when I take 6 times 3, I get 18. So if I come back again over here, let's think about working backwards. This is where I ended. This is where I ended. My middle step was written as 4 terms. And what it did is it took this term that I ended with and split it into these two, -4 or -6x and +2x. So I'm going to do that same thing here. So once I get to 18, the 3 times the 6, I'm going to write this, I'm going to break this middle term up into 2 terms. So what we're going to do is we're going to look for 2 numbers that multiply to 18 and add to 11. Okay, so I think about the factors of 18. 1 and 18, I'm not going to be able to get 11 from that. 2 and 9, oh, there it is. 2 plus 9 is 11. So I'm going from this last step to this middle step here. So I'm going to rewrite this 11x as 2x plus 9x. So I would have 6x squared plus 2x plus 9x plus 3. 1 second. Okay, so then we think about where we go from here. Well, last class we learned that when you have 4 terms, you factor by grouping. So that's exactly what we're going to do. So what we did is we took this trinomial and we manipulated it to make 4 terms. So now when we group these two, take the greatest common factor out of each. So I can take a 2 and an x out of this first group, and I'd be left with 3x here plus 1. Then from this group, I can take out a +3, and I'd be left with 3x plus 1. This is a good thing, because when we factor by grouping, those 2 binomials left over have to be the same. So now we take that out, and that quantity is going to go in 1 parentheses, and then what I have left is 2x plus 3. Okay. All right, let's look at example C, and then I want you to pause the video, and I really want you guys to make sure you're trying B and D on your own, because if you're just watching this video and not trying any, it's not a good way to learn the material. Okay. All right, so let's look at C. I'm going to go through this factoring flowchart every time. So let me we'll start and we'll look at both at the same time. Okay. So I see 2x squared minus 3x minus 2. Is there a greatest common factor? No. Is there a difference of squares? No. Is a equal to 1? No. So now we're going to use this A to C method. Okay, so we're thinking about working backwards in order to get to my 2 binomials at the end. So the first thing we do is start by multiplying A and C. So 2 times -2 is going to be -4. And I'm trying to manipulate this trinomial to form the middle step of when I would multiply it out. So I'm trying to get here. So I want to know two numbers that multiply to -4 and add to -3. Okay, so if we just think of positive factors of 4, and then we'll see what we could make negative in order for that to happen. Okay, well, 2 and 2 isn't going to work. But if I make this 4 negative, 1 plus -4 is going to give me that -3. So what I'm going to do is I'm going to manipulate this -3. My first term stays the same, so 2x squared. But instead of writing -3x, I'm going to write plus 1x minus 4x. So I'm working backwards. Here's where I ended. This is where that came from. So I'm working backwards here. We've got 4 terms, so now we can factor by grouping. So we'll group the first 2 terms and the last 2 terms. I should have also mentioned up here the order that you write these in. So if we would have written -4x plus 1x, that's okay. We'll all get the same answer. Our work in the middle will just look a little bit different, but your factors would still be the same. Okay? All right, so when we take this x out, I'd be left with 2x plus 1. And then here, we want to make sure we take out the greatest common factor. So since both of these are negative, I want to take out a negative. And then I would also take out a 2. Okay, that changes this to positive 2x plus 1. Again, that's exactly what we need. If those two binomials aren't the same, you made a mistake. So then that gets taken out as my greatest common factor, and I would have x minus 2 left over. Okay, so pause the video and try these on your own, these next 2. All right, so let's check our work here. So we run through our flowchart. Not a greatest common factor, not a difference of squares, A is not 1. Okay, so we're going to be working backwards here. So start by multiplying these two together. 5 times 8 is 40. I'm trying to break up this middle term. I'm trying to go from this step to this step. Okay, so thinking of factors of 40. 1 and 40, not going to work. 2 and 20, not going to work. 3 doesn't go into 40. 4 and 10, boom. That's where I get 14. So the 5x squared will stay the same, and in no particular order then, we'll have 4x plus 10x, and then plus 8 at the end. Okay. We'll group. I can only take out an x here, and I'd be left with 5x plus 4. And then I can take out a 2 from this group, and I'd be left with, again, 5x plus 4. This is good. These two binomials are the same. So my 2 final factors would be 5x plus 4 and x plus 2. Okay. Let's see how we did on this one. Go through the flowchart again. No greatest common factor. Not a difference of squares. A is not 1. Okay, so we're going to work backwards, going from here to here. So 3 times -2 is -6. Okay. We need to find two numbers that multiply to -6 and add to +5. Okay, so I think of factors of 6, 1 and 6, 2 and 3. Once again, they need to add to +5. So while, yes, I could say, well, 2 plus 3 is 5, 2 times 3 is not -6. Okay, so this one's not going to work. Okay, so if I make that one negative, -1 times 6, -1 plus 6 is +5, -1 times 6 gives me the -6. Okay, So we're going to break apart that middle term. So 3x squared minus x plus 6x minus 2. Group, group. Take out the x. We've got 3x minus 1. Here, I would not take out a negative because I want this to stay negative in here. So I'm going to take out a positive 2, and that'll leave me with 3x minus 1. This is good. So now I get 3x minus 1 times x plus 2. Okay. So that's our final factoring method. So now what we're going to do is we're going to put everything together and talk about how factoring is used to solve quadratic equations. So far, the only way that we have talked about how to solve is by using the quadratic formula. So the quadratic formula, the solutions tell us where we cross the x-axis. Okay, so the other method, the next method we're going to talk about is when it can be factored. So the zero product property is used to solve quadratic equations when the equations can be factored. So not everything can be factored. Factoring is much more efficient than the quadratic formula. The quadratic formula can always be used, but you guys have seen how it's just a little bit more work. So breaking it down like this is much more efficient. Okay, so the zero product property tells you that if P times Q is 0, okay, so if two values, if two numbers multiplied together gives you 0, then that means that either P has to be 0 or Q has to be 0. Okay, so if these two numbers multiplied together are 0, one of them has to be 0. It's the only way for mathematically that to happen. All right, so let's look at this. So whenever you see an equal sign, that means I want it solved. I want to know what value of x makes this equation 0. What value of x makes this equation 0? Because again, when we're solving, we're looking for where the graph crosses the x-axis. So when I look at this one, what I want to know is, all right, if this is my quadratic equation, I want to know when my y value, and that's my output, that y value, if I'm looking for where I cross the x-axis, that y value is always going to be 0. Okay, so I want to know when that's 0. So to check and see if it can be factored, we will follow our flowchart. There is no greatest common factor. This is not a difference of squares. A is 1. So this is where now different A is 1. So we're going to find two factors that multiply to get C and add to get B. Right? So if we again think about working backwards, we got to keep our 0 over here. These are a little bit easier because we can just say, all right, I know to get x squared, both of these have to be x. I know if these last two numbers have to multiply to negative 12, one quantity has to be positive and one quantity has to be negative. And now I need to think about factors of 12 that add to negative 1. So I think 1 and 12, no. 2 and 6, no. 4 and 3, those are only 1 apart. So if I make the 4 negative and the 3 positive, they'll add to negative 1. Okay? So now we'll apply the zero product property. Okay? So again, the zero product property tells me that if this times this is 0, we can kind of treat this as our P and this as our Q. So if this quantity times this quantity is equal to 0, then that tells me that either x plus 3 has to be 0 or x minus 4 has to be 0. So the two solutions, if I just solve for x, would be x equals -3 and x equals +4. Okay. Let's look at another one, and then I'll again give you a couple to try on your own. Okay. So I'm looking at this to see if it can be factored. Again, that's where we always want to start, see if it can be factored. There's no greatest common factor. It's not a difference of squares. A is not 1. Okay, so I'm going to have to do the AC method, break apart that middle term so I can factor by grouping. All right, so we'll start. 2 times -5 is -10. Looking for two factors that multiply to 10 or -10 and add to 3. Okay, so I see, all right, if I make that 2 negative, these two multiplied together gives me -10. Add together, I get +3. Okay. I see this equal sign, so I know I'm wanting to solve that. I want to know what x is when y is 0. So again, I'm looking for where we cross the x-axis. Y is always 0. So always keep 0 over here since we're solving, not just factoring anymore. And let's break this middle term up. So I have 2x squared minus 2x plus 5x minus 5. Group and group. Always keep the 0 over there. I can take a 2x out of this group, and I'd be left with x minus 1. And I can take a 5 out of this group, and I'd be left with x minus 1. This is good. These binomials are the same. Keep that 0 over here. My first factor would be x minus 1. My second factor would be 2x plus 5. So if I'm solving for x, because again I've got an equation and we always solve equations, if this quantity times this quantity is equal to 0, then that means that either this is equal to 0 or this is equal to 0. So when we solve, this would be +1. And when I solve this one, this is going to be 2 steps. So 2x would equal -5. And that would be -5/2. So I would get in the habit of leaving your solutions as a fraction like that, just in case your decimals are repeating. So if you just always leave it as a fraction, you won't even have to worry about it. Okay? All right, why don't you guys again pause the video and try these two on your own. All right, let's see how we did. So I'm solving this quadratic equation. That means I want to know what is x when y is 0. Where do I cross the x-axis? Okay. Always start. Is there a greatest common factor? Okay, there is in this one. So if you did not take out the greatest common factor first, think about what you guys are doing. That means you have to multiply 2 and -90 together. And then you have to look for factors that multiply to -180 and add to 24. No, thank you. So always, always, always take out your greatest common factor first. By doing that, look what happens. We made a equal to 1. These are so much easier to factor. Okay, so much easier to factor. So we'll keep that 0 out here. And let's work on this. So a is 1 now. So we're just looking for two factors that multiply to C and add to B. So we list out, let me still frame the room here, factors of 45. 1 and 45. I should also say, all right, we know that both of these are going to be x. They have to multiply to a negative, so that means one's going to be negative, one's going to be positive. 1 and 45, can't get 12 from that. 2 doesn't go into 45. 3 and 15, ooh, I can get 12 if I make this 3 negative. So these two numbers multiply to negative 45 and add to positive 12. Okay, so now this one looks a little bit different because I've got this 2 out front. Okay, so sometimes we will have 3 factors. So then we can think, all right, if P times Q times R is 0, and I just added that R because that's the next letter in the alphabet. So treat that as P times Q times R. One of those factors has to be 0. So either 2 would equal 0, x plus 15 would have to be 0, or x minus 3 would have to be 0. Well, this doesn't make sense. 2 is never going to be equal to 0. So when you just take out a greatest common factor, it really has nothing to do with your solution. So you can just kind of disregard it if you're just taking out a number. If there's an x in it, then we would have to use it. But if it's just the number, you can kind of disregard it. So that means that x would be either negative 15 or positive 3. So again, what that means, if I asked you to sketch what this would look like, when we find the solutions to a quadratic equation, we are looking for where my graph crosses the x-axis. So if you get these two solutions, this means that our parabola will cross when x is negative 15 or positive 3. Okay, so if I were to just sketch it, right now we don't really know how far down it goes. So this is all I'm looking for, an extremely basic sketch. Do you understand what you're doing when you're solving a quadratic equation? Okay. All right, so for this one then, we go through the chart. There's not a greatest common factor. Is there a difference of squares? Okay, well I don't see a b term. I see that x squared and 25 are both perfect squares. So this is a difference of squares. So this will factor to x plus 5 and x minus 5. So if one of these has to be equal to 0, that means that x either is going to be negative 5 or positive 5. So and what that means, if I were to just sketch a really basic graph, here's negative 5, here's positive 5, my parabola would look like that. Okay, so please, please, please use this chart. Have it sitting off to the side. Have both note outlines out when you're working on your homework so that you can look at all these methods.